Millennium to power millennium. Good morning, namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, April 15, 2022, Friday, 3:06 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक अप्रैल 15, 2022, सुबह के 3:06 शुक्रवार। And topic is same. Little change in topic, almost it is same. And this is at one end real quality requirement, on other end of this topic it what we do, and in between it is can see read yourself, that is quality requirement, coordination engineering only way, coordination engineering only way, and quality requirement is must. Project works, designs, contracts, reliable engineers, power of communication, concrete specifications, civil engineering, safety, health, environment, methods, disputed claims. What do we do? That's what do we do is a question here. What do we do? And here is, you can see first of all my connection to you through email, that is Suraj SURHA underscore engineer ENGINEER at yahoo.co. And this is my Chartered Engineer India title, also International Professional Engineer India title, that's valid for 5 years, and Arbitration Engineer, that is effective certification since fall 2022. This is civil engineering, and you can say all these titles are formal, not academics but professional, and that is, you can say civil engineering. I am FIE, that is Fellow of Institution of Engineers. It's a Institution of Engineers, and that is International Professional Engineer India, that is, you can say, a name that comes from International Professional Engineer Agreement countries, of which Bharat India is one, and arbitration engineer comes after approval, and my name exists on II panel. And then this is certification of International Professional Engineer India. This is certification of Chartered Engineer here, Civil Engineering Division. This is linked to Fellow membership of Institution of Engineers India, and that's why it's here. And you may say then this arbitration certificate, vision engineer, and this is here. Its number is Fellow 0818353, and is returned by virtue of expertise in field of arbitration and for empanelment as an arbitrator in panel of institution. This is what it says. This certificate has been issued, and here is quality requirement file. This is coordination requirement file. I close C file now. I close arbitration file now, and then we have these two files. I'll open specifications concrete file, that is from Japan, which we have been discussing, and that's here. And I shall also open another file, that is for white book of FIDIC. This is a specification for Japan, and here we have signals. Let me see first of all how signals are working, so that I should be mind free. Well, it's okay currently. Let us see. Currently it's okay. I can't say. Now my talk is about quality, how quality works, and that's most important point. How does we would not get in, that point is very important one. Why I always stress on quality? Because quality lies in my blood, you may say. Real quality, or you can say real quality and real coordination. When I say real quality, means it is something, it is engineered quality. It's not simple statement of quality I'm making. It's not simple talk of quality, but stress goes to achievement of quality. Everybody wants to have quality work. Everybody intends to get it, but how many percent do we get? That is one point in time. How many percent do we get it? That is very, very important from every viewpoint. Do we get it? You raise your question yourself about yourself if you are educated person, or even if you are not educated very well, quality can be understood by everybody. There is no way we can't understand. You buy whatever item from market, you know what quality it should have. Even if you eat something, say biscuit packet you buy or some other item you buy, you know what it should be. You know how it you should feel in its consumption, that is of consumable items. But otherwise also, you know, if you buy a mouse of computer from market, if you buy some other item, even it may not be very expensive, but we know what it should work for, what performance you should get out of it. That is what its virtual quality is. But I'm not talking about, I'm talking in general. When you pay something to someone, you must get back that. In terms of quality, product performance, product, if your product doesn't perform, at least it should perform. It doesn't perform in a way it was, or it doesn't perform to your requirement, you will not use it, and you will feel crazy about that. Why did I spend money? And of course it happens sometimes that for a small product nobody goes back to that shop because of time, because of time and because of many reasons. Okay, next time I shall not buy this product. Making that decision, we help, we support that manufacturer in a way we should not. You can see signals are again 0 0, and that is problem always with this. Every day I talk of this and I can't help it. That is what I say. I write to them, they say we did it. I yesterday also told them, you told me this is corrected, but it's worse. And I feel ashamed every time to complain about this, because how long after all? That's why I say there is no professionalism. Professionalism does not exist at all. Okay, we say it is digital world, it is computer world, it is this world and that world. You know what is happening? We have crowds of people in our country. We have crowds, millions and millions in every field. Like in engineering, in sciences, you see it's 0 and 0 again. And how to move further? Really, it is shameful for me to talk every day. Those people who are responsible for this, they don't have any degree of shame. Unfortunately, this is Airtel I'm talking about. So I should not speak in public like this. But after all, it is public forum. It is online, live. It is not personal. It is internet. And they should think about that. 0 0 0 0 0 0. Shame. Again, I am fed up. Where is professionalism? They always say we have experts, we are this and we are that. They are really expert in sending messages indeed. Yeah, day before yesterday I complained immediately. We'll do it. They talk to me, 2 or 3 persons. We'll set it. We'll send person, and they did next day sent a message. We have done everything. It's perfect now. You can use. But when I used it, I did not find. Still, it was worse. Means there is no change. That's what I say. Professionalism does not exist at all, and we must feel shameful of this. Whatever engineering it is, civil, electrical, mechanical, electronics, or digital, or what, there is a crowd of professionals everywhere. People claim they are educated, but there exists no degree of professionalism, no degree of quality system performance anywhere. And that is really shameful on our country. In fact, why it's like that, why are we not serious, that question. And that's why I write all these topics in this title. Where do we stand? For example, now it's giving 436 kbps wide video, 27 fps frame rate and 79 kbps, or it's still better, but immediately after a few seconds we'll find it is 00, and that's what's problem is. Means there is no constant conduct by signals even. This means they don't bother. I don't know this science, I don't know. Now it is only 6 fps frame rate, and it will become 0 also. Yes, 00. Now all these three are 0. I was talking to you, now it's just only 20 seconds. It's 000. And it's 000. I'll read on 000. Video bitrate 00. Frame rate 00. Audio bitrate 00. And that's problem. Still 00 goes on. And I'm watching this signal. Now it goes again 9 fps. 24K. Means what to do with these people? They can't move their trains of signals rightly on right track. What's happening? There's again 00 and 0. That's why I say 00. I'm working on 000. I can't guarantee. I am not sure whether the voice is being recorded or this video may die soon. That's what's happening, and we don't bother about this. Quality in engineering does not exist. Quality does not exist even in electronics engineering, internet engineering, you can say. How? And it's live and talking. I can't change anything. I can't pause it. It's live. I can't. Yes, I can close my video again 000. That's what it is. It's still not 1 minute over 2 or 3 times it is 0, and it continues 000. That's what I say we should worry about. No, it's not 00 now, 38 fps, and let us see how long it goes on. This is video bitrate 590, frame rate 38, and audio bitrate 92. Again down, and this is 102 kbps video bitrate and 7 fps frame rate and 17 kbps. It's like that. And I don't know, and it keeps on changing. There's no a gap of even 5 to 10 seconds. It remains constant. It doesn't remain constant, and that's my worry, that's my concern. What to do, how to solve it? I don't know how signals move, but it impacts on performance of live. Even it's not live, we can't see signals that time, but it says that I'm not working. It doesn't work that time, and that's problematic. In fact, that is problematic. We can say it should work, it does not work. Same thing is happening now. It is good signal, to be very frank. But let us see how long does it work like this. It's 454 kbps video, 43 frame rate, and 103 kbps audio. And let me see how long does it work like this. Let me see, I'm just reading it so that at least I should also, so it has gone. Let me see how it's working. I actually reconnected that one, and it's okay. Let us see how does it work. Does it work at all? It's 000 completely 0. That's nonsense. It is now 0 and 0. How to handle this? I don't know. Airtel can't solve this problem. They fail to solve this problem. They don't observe anything, I understand. There is no one there in Airtel to observe this issue. I am therefore very much upset. Now signals have come. This is what is happening. Well, let us continue. It's only 12-13 minutes since I started this video. I don't know how long shall it go, but let's continue our way. There's no further meaning to just criticize. I was talking then about real quality issue, which is very important for everybody. Quality and coordination can't be ignored. We have to say that. And real quality and real coordination is sorry. It's not obligation. It's not an obligation we do on people. It's a requirement. Real quality, real coordination. We can't say that we do any obligation on customers. You have to do that. It's your profession. Customer requires service. That's why customer pays you. But no customer. I think people are not very serious, and they think that Okay, let you enjoy this unlimited this and that, but this is what is unlimited. Quality of singles is down means quality of recording is down. So this is really quality. We have to say real quality, but there is no real quality. It's just you just use it to an extent you can use. Otherwise, don't raise questions. They will answer you immediately. We have set it right, and they won't set it right. So coordination we have to consider. We can only speak. We can only tell them, but solution they have to do. If they think only of business, then they will not solve it. They will ask you many points. This recording is important. We shall talk to you. Our representative shall talk to you, and this talk is very crucial for us. But this is only for sake of people. They record it, and otherwise, as far as real quality is concerned, there exists nothing here. Well, all our friends others no leave it behind, and we can say engineers have to do their job. There's no other way out. If you can't do your jobs, you can't handle, it's different. Means successful without any problem you can be, and we require to establish both domains permanently, and engineering professions and also other walks of life. There is no other way out. If you have to perform, you should have quality performing in applications, and as well as everywhere you can say quality should exist in every field, and that's important. Actually quality field is quite different. People consider system is fine, doesn't matter. I don't accept that. So yes, system is a requirement. We have to establish system, but system can work only when people are sincere, people are having working quality, people have character. I mean, I'm not talking of personal character, I'm talking of professional character. Quality can exist, can come only when you have your own quality. Quality means you are punctual, you are regular, you are concentrating person. You're not just showing that I'm busy and I don't know anything. Look busy and do nothing is doesn't mean you do. Means you have to accept responsibility, you have to dedicate, you have to think, you have to analyze, and you have to try to find solution to problems. Otherwise there is no justification of your survival in that. Engineering means facts, engineering means business, engineering means results, engineering means orientation. And if you can't do that, engineering you have to learn every day new one, and that's engineering. Engineering doesn't remain constant. And people say technology, yes, I agree with that. It is technology, it keeps on changing. New items are coming in every day. These come, they keep coming, and these previous sometimes are obsolete. But it doesn't matter that you don't care about that. It's not civil engineering, it's data engineering, it is electronics engineering, internet engineering, internet of things. Likewise, all quality requirements and all coordination requirements, the coordination every day it has to rise. Coordination has been falling, in fact. That is my worry. Coordination, you call it coordination or you can call it coordination engineering, it should move upward every day. Mind should work faster, but unfortunately minds are collapsing because of data, because of computers, because of use of computers to an extent. Now it's too much, and people forget calculations. People don't concentrate, they concentrate only on views, only on films, only on whatever you say. Coordination level has gone down, and that forced me that we should tell people, we should remind them that coordination is a part of life. Even if there exists no engineering, anyway, if you don't use engineering, you're not an engineer, doesn't matter, but coordination still works. Your daily program, daily schedule itself is a coordination part. What time you have to get up, what time to do this and that also a kind of timetable schedule. It's a part of coordination. If you can't coordinate that, if a student cannot coordinate their own time schedule, then the student cannot study properly. That student shall remain in panic. Okay, I planned this for today, I could not do it. And this applies to everyone all over the world. Time schedule is important. There should no politics or something else in that. Time is your own money. If you lose time, nobody can get you back that time. If you take more time on that, means you will miss time for some other thing. If you are so sincere, you make a program that I can't waste my time as well. Time is very important for everybody, and you have to value time, you have to save time, you have to allot time, and that's what part of coordination itself it is. you use coordination means in this period I have to do this, but if you can't do this, you don't worry about that. You don't know why did I miss it. You don't even check it. And that's where engineers today is, that engineer has to deliver, and not only engineer, everybody has to deliver something. Okay, if something is beyond your control, that is different, and you should know that this is beyond my control, and you should keep a margin on that. But you don't even keep margin because you don't think, you're not serious, and seriousness is very important in work. If one is serious, one can think of seriously, one can know, okay, no, I have to do this today itself, I have to finish it. If I don't do it, I would not waste time. And that's why coordination is all about. Coordination doesn't mean getting information only, but keep yourself busy also. And that you can also call part of quality, that you won't change, you will keep, you'll maintain it. There is no you can say there is no concession that can be given to quality requirement or to coordination requirement. Both move together. Quality is a destination and coordination is route on that, a process. If you miss coordination, you can miss quality or you delay it. Achievement is delayed. So we have to understand these points. Quality and coordination, these no one can teach you. Yes, quality system can be taught, quality specifications can be taught, that you have to learn because of your specialization or because of your working experience or because of your wherever you are working, what do they expect of you, and that's important. You have to learn that, that can be learned. But nobody can teach you coordination, because coordination comes from internal understanding. What is your problem? As much as you jump in, or you can say jump on rise, you rise on stair of progress, or in your career, or you can say you can move into subjects into depth, and you know there are other links to one subject, and you got to that, and that connection to those links and extracting information about what think or to solve problem. That's what is coordination. Coordination is a collection of information, doing information itself. When you do something, you will find more and more energy on that, and more information is required. Or you can get some information from your working. It's like cause mistake. Because of this, you made a mistake. We have to learn that. I mean, learning is also, a coordination process can teach us everything. You may work on working designs, you work on manufacturing or construction procedures, or continuous assessment for works, consideration of quality goals in all works is a must. You cannot say no, and that's very important. Have to fix real quality in Bharat, India, come what may. No excuse for any concessions. Why to excuse for concession? No, I don't need any concession. If I am good person, I value time, I formation, and I concentrate on activity. I don't I if I concentrate, if you don't concentrate on your worksheet or in MS Word or whatever, I'm talking very simple, which everybody does. If you don't concentrate on calculations, you will miss something, and worksheet shall give you different answer. It usually happens. Means a little disturbance on concentration can lead to something. So when you work in a quality way, you have to think of that, the focus on that only. Work's quality cannot be compromised. There is no way. We don't intend to compromise just in name of what you can say, just in name of fragile system. A system is always fragile because you did it. It's not solid, it's not founded, it's not RCC like it is. It's your own system. You say, I'm going to work this way. Okay, you prove this, and it doesn't contravene quality system. And you say, no, this is my way of working. I prove it, I do it. So do it in practice. It doesn't matter. That's all system you feel, but it may fail because you have not tried it in every respect. And that's what I say. I don't want to go into details of that. So we can only say that I could not find this anywhere, existence of quality and coordination, and that's why there are all red lines, and we'll just go to coordination file just for another way. So that I have to jump onto other one, and that is concrete file. So it is now a real coordination I'm talking of. It is engineering projects I'm talking of, and public engineers I'm talking of. That's what is important, and we have to see this, how this work, how it's important. Communication support for reliable coordination, it is all that, and we have to go to specifications, and that's also very important point. We have to spend. Then I'll go to other file also, and that is, you can say, that would be, this is fabrication of reinforcement. We were talking yesterday in collapse, system collapsed, and they're going to continue it, and we are somewhere here. Assembly of bars we did, and I think we are on formworks. I still remember we are on formworks, and we are reaching formworks, and we did many items of formworks, I think it is 95 somewhere. Let us see where. Yeah, it's form work. We did form work and form work ensuring the vertical loads we discussed, horizontal loads we discussed, lateral pressure of concrete also we discussed. So I think we will discuss lateral pressure of concrete now, because the formula something given the understanding is very important. Lateral pressure of concrete. I have to discuss about this in this talk, and let me see what's on with this. I'll be back in a couple of seconds. So here is the lateral pressure of concrete. We're talking is very important on lateral pressure. We talk it clearly. What is lateral pressure? How does it work? And that's also very important point. Let me check signals. First working out 000. That's problem. Okay, let me continue. If it records fine, otherwise what to do? I know no way. Just wasting time is no use. So lateral pressure of concrete. Formwork shall be designed taking into consideration lateral pressure of concrete. And that's very important point. Formwork shall be designed taking into consideration lateral pressure of concrete. Since lateral pressure of concrete varies depending on structural conditions, concrete conditions and construction conditions, its value shall be determined taking these factors into consideration. What are those factors? Let us see. These factors are structural conditions. Structural conditions we discussed yesterday, concrete conditions we discussed yesterday, construction structural conditions means cross section. What is the structure actually? Cross sectional dimensions, amount of reinforcement, and concrete conditions on what type of material it is, what's mixed proportion, what is slump, and what is the retention time, setting time, concrete temperature. Construction conditions are placing rate, placing height, compaction method, whether it, well, it's question of analysis. These are classified into structural conditions, concrete conditions. Construction, experience tells you everything about that. What you deal with means, of course, what type of formwork it is, how congestion steel it is, and what's temperature it is, what's mixed proportion. Means everything is there. In fact, is only classification, that is structures, conditions, concrete conditions, construction. In factors, if factors contribute to you can say the factors contribute to an increase in lateral pressure. How it is that increase in lateral pressure? If factors contributing to an increase in lateral pressure are involved, it is necessary to appropriately increase lateral pressure. If factors contributing to an increase in lateral pressure are involved, It's necessary to appropriately increase lateral pressure values used for calculations. That setting time, temperature, and placing rate of concrete vary considerably depending on outdoor air temperature, materials used, production and construction conditions. If slump retention time is long, if slump retention time is long, setting is delayed, or placing rate is increased, as in case of concrete placement during winter, care need be taken because higher than expected lateral pressure may act on formwork courtesy. That's in winter. It's difficult to indicate in construction. Construction standards of the specification, a lateral pressure formula reflecting influence of various factors affecting lateral pressures. Lateral pressure values to be used for formwork design shall be determined appropriately on constructor's own responsibility. That's a very important point. Lateral pressures values to be used for uh, formwork design shall be determined appropriately on contractors on responsibility, constructions on responsibility, taking into consideration construction speed, economy, safety, and other requirements of construction or constructor, various factors affecting them. One way to do is design formwork by measuring actual lateral pressure by installing lateral pressure cells or check lateral pressure during placement of concrete. One way to design conservatively is to determine lateral pressure acting on formwork by regarding lateral pressure as fluid pressure. Term fluid pressure refers to pressure, hydrostatic pressure, in case where gravity acts on fluid in a stationary state. Fluid pressure is calculated by assuming concrete as fluid and multiplying unit mass of concrete by gravitational acceleration and placing height as follows. Here is PW is equal to this is fluid mechanics and we say use fluidity concrete such as self-compacting concrete and high-strength concrete often show distribution patterns resembling those of fluid. Construction special concrete, okay, we'll see that. Therefore, a general rule we have to see that design be conducted assuming fluid pressure. If unit mass of concrete has been determined, it may be substituted in equation. All right, now design than fluid pressure. If relatively low slump concrete is mentioned in construction, construction standards placed under certain conditions, such a layer of thickness 0.4 to 0.5 meter or less and a placing rate of about 1 to 1.5 meter. The lateral pressure acting on formwork is often substantially lower than fluid pressure. Various practical lateral pressure formulas have therefore been proposed based on results of experiments paying attention to various factors affecting lateral pressure. Equations shown below are long-used practical formulas for roughly calculating lateral pressure in case where normal Portland cement is used and concrete with a slump of about 10 cm or 100 mm or less is poured into formwork and compacted by use of internal vibrators. So let us see. In view of experiment conditions under which formulas were derived, I can say upper limit of values calculated from formula is 150 kilonewton per meter square. Says upper limit of values calculated from formula is 150 per meter square for columns, 150 kilonewton per meter square for columns and 100 kilonewton per meter square for walls. Because these formulas do not consider final placing height, calculated lateral pressure values may become greater than fluid pressure values depending on placing rate, concrete temperature and final placing height. Since our maximum value of lateral pressure is usually not greater than fluid pressure is used when calculated value is greater than fluid pressure. In case of wall, there are no significant differences from lateral pressure of a column. Formula for column therefore may also be used for wall. So let's say what it says. Formula is P equal to WC divided by 3 bracket 1 plus 100R over T plus 20 less than equal to 150. Let us see what does it mean. It means it says that Laplace is just it says this is for column, and for wall it is R is greater than or equal to 2 meter per height, and says P is equal to WC over 3. WC is concrete as in above case. WC over 3 of course H over 3, 1 plus 150 plus 30 R over T plus 20 less than equal to 100. These are two. If R is less than 2 meter per height, and here they are said if R is not given there, okay, R is less than 2 meter per hour, formula of column may be used. Where P is lateral pressure, that's P is lateral pressure, kilonewton per meter square, but if calculated value of P becomes greater than PW, P is assumed to be equal to PW. Now fluid pressure PW is fluid pressure kilonewton per meter square. W is the unit weight obtained by multiplying unit mass of concrete by gravitational acceleration, that's kilonewton per meter cube. R is placing rate meter per hour. T is concrete temperature formwork in degrees Celsius. So this is your placing rate is R here. You can see this placing rate. Let me point up a little. Here is placing rate R. It is the lateral pressure of concrete with slump of about 100 mm, and this is lateral pressure is here, and this is placing rate R, and that is meter per hour. 1 2 3 4 5 meter per hour, and this is lateral pressure 0 to 160 kilonewton per meter square, and is maximum value of lateral pressure permissible for applications of formula. This is, and there are temperature variations on this. You can say this is 35 degrees Celsius, this is 30 degrees Celsius, 25 degrees Celsius, 20 degrees Celsius, and this is 15 degrees Celsius, 3 degrees. You can see if you go up and up, you will find higher temperature gives lateral pressure which is lower, and lower temperature means higher, means in winter pressure is higher because of setting delay, and here temperature is high, 35 degrees. You can say lateral pressure is lesser because it sets in quickly. That's the only way. This is indicative, means you can't rely on this information. You can check out your own. You have to find your own formula. You have to use that formula yourself, and that may be way better. Lateral pressure of concrete slump about 100. Now we go back to the other one, and this is lateral pressure of concrete slump about 100 centimeter or less, and this is less case, and it is same formula, same wall maximum. This is for wall, and that was for column. That's the only difference. You can see difference here, and you can see here 1 2 3 means these are different temperatures, and these are different temperatures, same thing, but the difference of course you can understand very well. Just indicative diagram it is. You can't say it's okay. You can calculate your own, depends on that. It's not very difficult because this is C 11 2 3 11 2 3, and I think this one. A distribution of lateral pressure of concrete with slump of about 100 cm. Let's see this one. First it says this figure shows changes in distribution of lateral pressure due to concrete. What are changes? As indicated by this formula, lateral pressure increases, placing height increases. Of course, lateral pressure increases as placing height increases. That's true. If 2 or more, that is 0.4 to 0.5 meter thick layer of low slump concrete are placed on top of another, increase in lateral pressure is in many cases hampered, especially at locations lower than a certain level. Because of decrease in slump of concrete in formwork, progress of setting, bonding with reinforcing bars, etc. In view of possibility of such changes, therefore, if tall forms are used, formwork line assuming that lateral pressure is constant at below a certain height, This assumption is based on fact because above mentioned formula for calculating lateral pressure from placing rate and concrete temperature do not include a term for placing height. Calculated lateral pressures remain constant, thus formwork is designed assuming that calculated lateral pressure's maximum value. I'll show you one file later on because I have to find that file. Real file I got on. This is just for this reference. It says here in A maximum value lateral pressure. This is placing height. You can say here this is a triangle which we know very well, so you can say this is variation in compaction by use of internal vibrators, and of course you have to do it. Other one is here, and that is B lateral pressure, and this way, and you can say final height is this. So you can say this is high, this is small height, and this is height. So it is same triangle over here, and then this is down because of setting of concrete. You got my point. Here this is zero pressure. Here's triangle. This is initial height, and when you raise height, you can say here this shift for some, that is for this portion, down also less. And if you say height at this constant is, let's say lateral pressure, it's a final height, and this is final lateral pressure. So the same thing formed here, and this you can say likewise you can consider. It's up to you. Lateral pressure distribution at initial stage of placement, that is A, and B is lateral pressure distribution upon completion of placement, and C is lateral pressure distribution calculated at design stage. Now let's say construction standards of this specification specifies a method for determining appropriate, let me see, single cell, very small single, let's okay, something is better than nothing, I can say that, that's all. What to do otherwise? Tell me, I'm helpless like you are helpless. So we can say construction standards of this specification gives a method for determining appropriate minimum slump for placement considering concrete structure and just my dear friend, construction standards of this document gives a method to determine appropriate minimum slump for placement considering concrete structure, and reinforcement, considering concrete structure and reinforcement conditions. It's therefore possible that concrete with larger slump than that of conventional concrete shall be used in civil engineering projects because minimum slump required to be retained until placement of concrete is completed. Slump of concrete at time when it is actually placed becomes greater than minimum slump since lateral pressure of concrete tends to increase with slump. It's necessary to determine lateral pressure in view of predetermined slump values and tolerate during construction planning. Equation which is given above practical formulas for calculating lateral pressure in case where high slump concrete is placed, that is above 180 mm pump concrete at rate of 10 meters per hour. I don't think it's 10 meters per hour is right, it's too much. We have to think again. 2 meter height is too much, 10 meter per hour. No problem, because we can't pour more than 400 millimeter each layer, and 10 meters per hour means it depends on, I can't answer this well, we just learn it, or less than at the final placing height of 4 meter or less. And now figure which is gone, C11, maybe here different one, and that's here C11 to 4. We can say, let's read first what it says. If where's that? Yeah, C11 to 4 shows distributions of lateral pressures calculated by using formulas. These distributions can be used as reference data when considering lateral pressure of high slump concrete. However, that's formulas reflect neither placing rates. I can say, however, that formulas reflect neither placing rates lower than 10 meter per hour nor influence of concrete temperature. In general, you can say in general, lateral pressure increases with slump. If therefore lateral pressure calculated by using these formulas is equal to or smaller than a calculated lateral pressure of concrete with a slump of about 100 mm, it is desirable that lateral pressure be determined taking a factor of safety into consideration. If placing height is in range of 0 to 1.5 meter, that's placing height, it's assumed that fluid pressure acts of course 1.5 meter. If placing height is greater than 1.5 meter and not greater than 4 meter, lateral pressure is calculated for each structural type using following formula. Column, let us say 1.5 WC plus 0.6 WC into H minus 1.5. Well, this is a generated formula. You may generate, let's see 1.5 WC plus 0.6 WC, H minus 1.5, that's for column. And wall is 3 meter or less, and that same formula 1.5 WC plus 0.2 WC, H minus 1.5. And wall with greater than 3 meters height, 1.0 WC. This is general trend line lower. H is lateral pressure and WC is unit weight concrete multiplying unit mass of concrete, and that's unit weight gravitational acceleration at second. Placing height is H. Now this is diagram, this is figure distribution of lateral pressure of concrete slump of about 180 mm, and it is here lateral pressure, that's 0 to 100. Here is height from newly placed concrete, that's 1. Unit mass of concrete is 2400 kg per meter cube. Placing rate is 10 meter per hour or less. Placing height is 4 meter or less. Column is this here. This is for column, and this is for wall here. Wall L, that's less. This here, meter or less, and this is greater than 3 meters. So you say this is column. Here pressure is more. The same point here is height. Height is same. This is pressure is more here in case of this. In case of wall 3 meter or less, it's further down here. And for greater than 3, it's here. That's what it says. And just this understanding if this is fluid pressure, we can say you may say this is like empirical world, no set formula. Spatial loads, what are these? We have to study about spatial loads, and we are gradually moving towards more and more understanding of concrete. Well, this is a concrete subject. I again try to suggest this is not my specification, this is not our country's specification, this is from Japan, and because these people are of course calculated, I'm finding this in this specification. I could not find all this in other specifications, particularly from Qatar even. But let us see, we have to understand, we have to get, after all we are at concrete, we are in engineering, we have to learn very many issues. Spatial loads, if influence of spatial loads expected to occur during construction, if influence of spatial loads expected to occur during construction cannot be ignored, those loads shall be taken into consideration when designing formwork, ensuring spatial loads defined here are eccentric loads. Spatial loads defined here are eccentric loads. caused by unsymmetrical placement of concrete. Horizontal component forces at placement caused by inclination of form bottoms. Uplift force effective to embedded sheets in hollow slabs, and other forces such spatial load shall be considered in the design where the effect may be anticipated. Spatial loads defined here are eccentric loads, eccentric, caused by unsymmetrical placement of concrete. Horizontal component forces at placement caused by inclination of form bottom. Uplift forces effective to be embedded shades in hollow slabs. Uplift forces effective to be embedded shades to the embedded shades in hollow slab, and other forces such as special loads shall be considered in design where their effect may be anticipated. Now, what materials? Materials used for formwork and shoring shall be selected taking into account strength, rigidity, durability, workability, effect on placed fresh concrete, aesthetics, and economy of concrete structures. Materials such as timber, plywood, and steel plate used for formwork should meet requirements of relevant. Okay, in cases when concrete structure requires water tightness, in cases where concrete structures require water tend to be damaged, deformed, and corroded through repeated use and relatively large loads. However, selection conditions differ depending on type of structure, frequency of use, or importance of location where formwork and shoring are to be used. Therefore, most suitable material should be selected after taking into consideration factors described in this section. Formwork shall meet required performance, construction, accuracy, and construction safety. This is my new one and this is my old one, you can see. Also here was, you can see this is revised one and this was previous one. Just for your information I would say. It's not moving, why? This is my another certification. This is quality file and this is coordination file and this is a concrete. I'm talking of formwork and shoring tend to be damaged, deformed, and corroded, that we have to consider about this, about the condition that should be used, that should be taken into consideration. Selection condition depend on what type of work we have, what's its architecture, what's its exposure. However, selection of condition differs depending on type of structure, frequency of use, importance of location where formwork and shoring are to be used. Therefore, most suitable materials should be selected. Formwork shall meet required performance, construction accuracy, and construction safety. Although formworks are usually used for use more than one channel use, 5 times for plywood, about 20 times for plastic forms, 20 times for plastic located forms, and about 30 times for steel forms. So plastic can be used 20 times and steel can be used 30 times. But remember, makeup is important here. As many times you use, you have to make it up again and again. And that's very important part. Again, it says that the specifications for pipe support, steel panel, foam formwork, and plywood for concrete formwork. All right. Recently, there's a trend to change plywood formwork material from trees such as German and Southeast Asia to needle leaf trees as part of countermeasures against global environment. In case of formwork made from needle leaf trees, It is necessary to consider that needle leaf trees have many knots and formwork made from these trees may curve easily, resulting in inadequate hardening of concrete. Compound plywood made of lawn for surface layers and needle leaf tree on inside or with surface painting or other methods may be used so as to prevent adverse effect on concrete quality. A plastic form can serve not only as a substitute for timber from Southeast Asia but is also effective for construction management. Now, let us say about ordinance on industrial safety. What it says, allowable stress of metals. For let's say stress of metals, it says allowable permissible bending stress and allowable compressive stress of steel members shall not exceed two-thirds of lower of following values. Yield strength or three-fourths of tensile strength. Allowable shearing stress shall not exceed 38 hundredth of lower of following values. Yield strength or three-fourths of tensile strength. Allowable working buckling stress of steel member shall not exceed these values. So these values are there. You can read them. Means it's all theoretical. And experience is more important than all these. So it says, for example, effective length of support, that is longest span of restraint position if support is restrained from lateral displacement. I is minimum radius of gyration of support, section mm, and then formula is limit ratio of length to width. These are all formula engineering ratio of circumference, Young's modulus, and allowable buckling is this. We can see this formula at this moment. We cannot go into details of this. Just reference it is. If you go to this specification, you can the standard allowable stresses of metal for formwork and shoring. It says species and then allowable stresses, bending stress, compressive stress, and shear stress. Species Japan red pine, Japan black pine. These are names of these species. Japan large arbor vitae, Japanese cypress, Japanese hemlock, Arcgion pine, Porthor for cedar, Japan cedar, fir, Japanese spruce, Abies, Western red cedar. These are needle leaf trees and bending stress is 13.5, in one case 10.5, and also compressive stress is 12, and in other cases 9, and shear stress is 1, in other case 0.7. Broadleaf trees, oak and chestnut tree, Japanese oak, beech, etc. So these are stresses given here. Allowable buckling stress of timber parallel to the grain shall not exceed these values. So we can go through these. Now, the important point is procedure. What it says in this case. Let's see. Bleeding water accumulates under bolts and steel bars. Bleeding water accumulates under bolts and steel bars used as tie members and causes water leakage after hardening of concrete. It's efficient to attach a brim so as to lengthen waterway. Hole at concrete surface should be carefully filled using resin mortar or other materials while taking into consideration water tightness requirements of hole structure. Design of formwork. Formwork design is a very important factor because it is formwork that's going to register forces from concrete. Formwork shall be able to maintain its shape and position accurately under action of loads by using appropriate bolts. Structure of formwork shall be such that it can be easily erected and removed. Vibration or impact resulting from removal shall not adversely affect concrete. Structure of formwork shall be such that it can be easily erected and removed. Vibration or impact resulting from removal shall not adversely affect concrete. Joints in sheathing or form panel should, as much as possible, be at right angles or parallel to member axis and be sealed to prevent mortar from leaking. Even if not specified, formwork should be designed to incorporate chamfers at all corners. It's a very important point. Even if it is not specified, formwork should be designed to incorporate chamfers at all corners. If necessary, temporary openings shall be provided. If necessary, temporary openings shall be provided at appropriate positions in formwork to facilitate cleaning, inspection, and placement of concrete. It is important to erect boards or panels at right angles or parallel to member axis so as to ensure accuracy of formwork position, shape and dimension, and also to prevent mortar leakage from sheathing joints or form panels. Proper chamfer strip at corner of formwork is useful for protection against impact damage during removal work or after completion of construction. Furthermore, such chamfers are effective in order to minimize effect due to atmospheric conditions or physical action. Chamfer is sometimes used at joints in consideration of appearance and constructability. It's very important point, this very small item, but we should care about, though we don't care. We think only for exposed corners, we don't think for all corners. Exposed corners is generally chamfered according to various specifications. And here is proper chamfer strip. Chamfer strip at corner of formwork is useful for protection against impact damage during removal work and after completion of construction. This is a very important point. Generally corners are broken during when you remove shutters. Furthermore, such chamfers are effective in order to minimize effect due to atmospheric conditions or physical action. Chamfer is sometimes used at joints in consideration of appearance and constructability. Now, this requirement is necessary. Let me see it. This requirement is necessary when inside of formwork is blockaded. This requirement is necessary when inside of formwork is blockaded. Cleaning and inspections are difficult after assembly or before concrete placing or when height of formwork is high and shoring shall be appropriately designed to ensure that all loads acting on it are transmitted to foundation. Shoring shall be easy to erect and remove, with joints and connections being appropriately designed to carry all loads. Foundations of shoring shall be such that excessive and differential settlement does not occur. Additional measures to appropriately raise shoring shall be provided to offset any settlement and or deformation during or after placing of concrete. It is necessary for shoring members to stabilize supports using sufficient lateral or diagonal bracing so as to possess sufficient strength and to be safe against buckling under vertical loads. When variance of load distribution occurs with differential settlement of foundation, temporary beams or other members should be used to distribute loads to vertical supports. Shoring should be designed to resist horizontal loads. By fixing both sides of beam and upper part of shoring onto existing structures or other supports, or by employing lateral and diagonal bracing. Also, for inclined formwork, care should be taken to ensure that shoring should not deform adversely under concrete pressure. Shoring should be designed to be removed easily and safely without causing any impact on structure due to jacks, wedges, anchors, or other measures. For load transmission at junctions, it is effective to firmly fix supports using butt joints or plug joints and connections and intersections between steel materials using metal devices such as bolts and clamps. Beams of considerable height should be connected together with lateral bracings to prevent rotation and collapse. To avoid settlement of foundations in soft ground conditions, distribution of floors or adequate strength affect settlement or deformation of structure during construction. Therefore, it's required that shoring be raised to ensure that structure is constructed in conformity with design drawings. Also, deflection caused by creep after construction may also require shoring adjustments. Generally, it is necessary to show amount of additional lift in design drawings. Settlement and deformation of shoring is normally caused by settlement of foundations, compressive deformation and deflection of shoring members, loosening of joints or connections in shoring and thrust of contact force faces. Amount of settlement and deflection should be estimated by calculations, past experiences, or simple field measurement, and be taken into consideration in construction. Now, before going to that one, I'd like to have a look on another file that's also important for us, and that is I put in FIDIC white, that is FIDIC file for designs, and that is which is a client and consultant model service agreement, that is from FIDIC. It's of course it's important one. This is for consultants, for designers. This file is, it's from FIDIC, but I'm just showing to you how it works. I'm not going to read all this. Only index in this case is general conditions, that is definition and interpretation about definitions of provisions, obligation of consultant, and that is scope of services, normal, additional and exceptional services, duty of care and exercise of authority, client's property, and meanwhile I should put a barrier here so that we know what we are talking about. We're talking about consultants and owners relations. We are talking about that, and that's very important. As I said, definitions, interpretations, and scope of services, normal, additional, and exceptional services, duty of care and exercise of authority, client's property and information regarding obligation of client, and that is information, decisions, assistance, equipment and facilities, client's personal services of others. In personal, supply of personal representatives, changes in personal, and then liability insurance, liability between parties, liability of consultant and liability of client, compensation, then duration of liability, limit of compensation and indemnity, limit of compensation, indemnity, exceptions, insurance for liability and indemnity, insurance of client's property, then commencement, completion, alteration and termination of agreement, agreement effective, commencement and completion, variations, further proposals, delays, change circumstances, abandonment, suspension or termination by notice of client, by notice of consultant, exceptional services, rights and liabilities of parties, payment to consultant, time for payment, currency of payment, third-party charges on consultant, disputed invoices, independent audit, general provision, languages and law, changes in legislation, assignment and subcontracts, copyright, conflict of interest, corruption and fraud, notices, publication, settlement of disputes, amicable dispute resolution, attempt to resolve, referral to mediator, appointment of mediator, agreement of program, written agreement to be binding, non-binding opinion, cause of mediation, failure of mediation, arbitration. Particular conditions, reference from clauses in general condition, additional clauses and appendices, scope of services, personal equipment, facilities and services to be provided by client, remuneration and payment, and then agreement. What is agreement? Language is very simple. This agreement made on this day of is between this and this. Hereinafter called consultant, that's called client. Client is first party, consultant is third party. Whereas client desires that certain services should be performed by consultant, namely whatever, and has accepted a proposal by consultant for performance of such services. And what are those services? In this agreement, words and expressions shall have same meanings as are respectively assigned to them. In conditions of client consultant model services agreement hereinafter referred to, following documents shall be deemed to form and be read and construed as part of agreement, namely letter of acceptance, acceptance letters you can say, conditions of client consultant model services agreement, general conditions and particular conditions, appendices, namely Appendix A, scope of services, Appendix B, Appendix A, scope of services, Appendix B, personal equipment, facilities and services of others to be provided by client, Appendix C, remuneration and payment, and then we have in considerations of payments to be made by client to consultant as hereinafter mentioned as client consultant hereby agrees with client to perform services in conformity with provisions of agreement. Client hereby agrees to pay consultant in consideration of performance of services such amounts as may become payable under provisions of agreement at times and manner prescribed by agreement. In witness whereof parties here to have caused this agreement to be executed this day and year first before written in accordance with their respective laws. Authorized signature of client and presence of name, signature, address of witness, and authorized signatures of consultant in presence of name, signature, address of witness. And then conditions. I've just tried to refer to you this for time being, and we will see. We'll just move on pages only because it's about not. I'm not going to detail it today. We'll take because as you can see, we can see this. It's not very long, very small, but I say small. We come back to it again. Let me go back to concrete. Just for information, it is the how shall move on this because this is your consultant, and you should know about your position, legal position, how it works, and that will predict. So that's what I take it back. We move this now. Preparation of form work, and I can say continue on this. Again with the breaker here, and here's break, and I can say now say preparation of form work, which is very important one, stock and through, and we don't want to miss something here, and let us see how signals performing, and it's about 1 hour more. Let's see how does it work. How signals, Form work should be secure, you know that. Preparation of formwork. Formwork should be secured using bolts or steel bars. Formwork should be secured using bolts or steel bars. These bolts or bars shall not remain on the surface of concrete after removal of formwork. Contact surfaces of formwork should be coated with a foam release agent. Dimensions of formwork and defects, whatever therein, shall be appropriately managed prior to and during placing of concrete. Formwork should be secured using bolts or steel bars. These bolts or steel bars shall not remain on surface of concrete after removal of formwork. Contact surfaces of formwork should be coated with a foam release agent. Dimensions of formwork and defects therein shall be appropriately managed prior to and during placing concrete. Steel wire in particular shall not be used for tying members. Steel wire in particular shall not be used for tying members of important structures because it may easily expand or be cut. When bolts and steel bars are exposed, to concrete surfaces, exposed portion may cause water infiltration, rust spots or cracks on concrete surface. Embedded parts of bolts or steel bars within 2.5 cm of concrete surface should be removed after chipping of concrete. Embedded parts of bolts or steel bars within 2.5 cm of concrete surface should be removed after chipping concrete. Hole created by chipping should be filled up with high quality water. Foam release agent should effectively prevent formwork from adhering to concrete surface and facilitate removal work of formwork. For foam release agent, many kinds of products are marketed for use with wood, steel or other foams. Main components of foam release agents are classified into paraffin, that is paraffin, mineral oil, animal oil, vegetable oil, synthetic resin and surface active agents, among others. What are these? Main components, keep in mind, main components of foam release agents or we can say shutting removal agents are classified into paraffins, mineral oil, animal oil, vegetable oil, synthetic resin and surface active agents, among others. Each foam release agent differs widely in uses, application amount, maximum number of applications, etc., depending on type of usage. A foam release agent may flow out by washing. You can say depending on type of uses, a foam release agent may flow out by washing with water. At time of cleaning, you can say a foam release agent may flow out by washing with water at time of cleaning, rain, etc., so that foam release effect may decrease. Also, construction joints may be polluted or a foam release agent may be entrapped in concrete during placement. Therefore, it is important to first confirm property and uses before using a foam release agent. Formwork shall be erected so that completed structure is within tolerances. Inspection standards of these specifications. There may be deflection of formwork, leakage of mortar, moment, inclination, settlement, looseness of connections, etc., caused by formwork prior to and during placement of concrete. When such troubles arise, it is important to take suitable measures immediately, if necessary, to prevent danger. Preparation of shoring. Shoring shall be prepared in a manner that ensures sufficient strength and stability. Shoring prepared in a manner that ensures sufficient strength and stability. Dimensions of shoring and whatever defects therein shall be appropriately managed prior to and during placing of concrete. Placing of concrete. In order to provide sufficient strength, in order to provide sufficient strength and stability for shoring, prior to shoring erection, adequate preparation and strengthening of ground should be completed so as to provide required bearing capacity or to avoid differential settlement. Sufficient compaction should be applied to backfilled soil. Sufficient compaction should be applied to backfilled soil when it is used as foundation material. When there is possibility that water may erode underside of shoring, precautions for treatment of water shall be taken. Care should also be taken to inclination, height, alignment and other factors so as to ensure that there shall be sufficient strength and stability during erection of shoring. Joints, connections and intersections of members. Joints, connections and intersections of members should be tight and free from gap and looseness. All joints should be aligned correctly. There may be movement, inclination, settlement caused by shoring prior to and during placement of concrete. When such trouble arises, it is important to take suitable measures immediately if necessary to prevent danger. Shoring shall be erected so that completed structure is within tolerances specified. Even in cases where tolerance for each part of shoring is small, enough to be commonly acceptable, there is any part, if this is some part that is affected by cumulative effect of such tolerances, it is necessary to evaluate such effects and specify tolerances considering a cumulative error. Removal of formwork and shoring. Removal of formwork and shoring. Formwork and shoring shall not be removed. Formwork and shoring shall not be removed until concrete has achieved sufficient strength to carry its own weight and whatever loads superimposed during course of further construction. Timing and the sequence of removal shall be determined taking strength of concrete, structure type and importance, member types and dimensions, loads imposed on all members, temperature, weather and ventilation into appropriate consideration. In cases when structure is subject to loads immediately after removal of formwork and shoring, concrete strength, structure type and characteristics and value of imposed loads shall be carefully considered in order to avoid harmful cracks and other damage to structure. Removal of formwork and shoring should be carried out. Removal of formwork and shoring should be carried out after concrete has achieved sufficient strength. Removal of formwork and shoring should be carried out after concrete has achieved sufficient strength. Removal of formwork and shoring should be carried out carefully so as not to damage structure. Timing of removal should be determined considering compressive strength of concrete, specimen cured under same condition as actual structure. Since specimens tend to be influenced by outside temperature of dryness, it's desirable to judge timing of removal based on curing method in consideration of these effects. It is difficult to provide general criteria for removal time of formwork and shoring because various factors mentioned in this section which greatly influence removal time, as many construction accidents can be attributed to erroneous judgment of removal time. Sufficient consideration is required for removal of work. When total load, now you can say there's a table given here provides suggested compressive strengths for determination of removal time of work, formwork for RC structures, when the total load acting on structure consists almost entirely of dead load. A longer period of curing may be required, and even after compressive strength stewed and formwork is removed, wet curing needs to be continued for a period. Generally, part of formworks which bear relatively smaller loads should be removed prior to other parts which are more important and bear more loads. For example, formwork for vertical members like columns and walls can be removed before those who are horizontal ones like slabs and beams. Formwork on lateral sides of beams can be removed before those at bottom. As reference only, not mandatory, reference values of compressive strength of concrete required for removal of formwork and shoring. And say type and position of surface, example, compressive strength, Newton per meter square is given here, and let us see what it is. And it says vertical or almost vertical surfaces of thick members and upper surfaces of inclined members, outside surfaces of small arch structures, and this says that sides of footings, for example, compressive strength 3.5 Newton per meter square, vertical, you can say vertical or almost vertical surfaces of thin members, lower surfaces of members inclined at 45 degrees or more, and inside surfaces of small arch structures, sides of columns, walls and beams, that's 5, slabs and beams of bridges and buildings, the lower surface of members inclined at 45 degrees or less, bottom of slabs and beams, inside surface of 14. Immediately after removal of formwork, concrete structures may not have yet have acquired specified concrete compressive strength, and structural system may be different. The structural system may be different from one expected in design. Loading may cause harmful cracks or damage to structure due to excessive stress. Therefore, it should be confirmed that loads imposed immediately after removal of formwork and shoring shall have no harmful effect on structure, especially formwork and shoring in general. Special formwork and shoring in general. Various types of special formwork such as slip forms, embedment forms, vent formed, water absorbing forms, etc. are available. Various types of special shoring such as moving shores, erection cars, etc. are also available. These formwork and shoring shall be used in accordance with special requirements for use. There are various types of special formworks. For instance, slip forms which move vertically for construction of high bridge piers. Slip forms which move vertically for construction of high bridge piers and water tanks. Forms which move horizontally or diagonally for waterways. Forms which move horizontally or diagonally for waterways, tunnel forms for secondary lining, and so on. And there are various types of special shores such as moving or truss shores for viaducts and erection cars, for cantilever erection of arch bridges. Formwork which is made from polymer cement mortar. Formwork which is made from polymer cement mortar, polymer impregnated concrete, fiber reinforced concrete, etc., and is used as a part of member as well as vented form and water absorbing forms which decrease surface air bubbles and rock pockets while reducing water cement ratio at concrete surface and raise impermeability of surface part of a structure, are used in environments where high durability is required. In addition, when using vented form or water absorbing forms for a thin concrete member, it is especially important to delay removal or to assure sufficient curing in order to avoid drying at initial stage. When using such forms, care should be taken to meet special requirements for use. I'll repeat this, it's a very complicated one but good one. There are various types of special forms. For instance, slip forms. Slip forms which move vertically for construction of high bridge piers and water tanks. Forms which move horizontally or diagonally for waterways. Tunnel forms for secondary lining, diagonally versus horizontally or diagonally for waterways, tunnel forms for secondary lining, and so on. There are various types of special shores such as moving or truss shores for viaducts and erection cars, for cantilever erection of arch bridges. Formwork which is made from polymer cement mortar, polymer impregnated concrete, fiber reinforced concrete, and is used as part of member as well as vented forms and water absorbing forms which decrease surface air bubbles and rock pockets while reducing water cement ratio at concrete surface and raise impermeability of surface part of structure, are used in environments where high durability is required. In addition, when using vented forms or water absorbing forms for a thin concrete member, it is especially important to delay removal or assure sufficient curing in order to avoid drying at initial stage. When using such forms, care should be taken to meet special requirements for use. Since an embedment form is generally a thin component, embedment form is a thin component, cracks and chips may occur due to its own weight impact. It's during conveyance and installation. Therefore, it's necessary to pay attention to conveyance method or method of hanging. Also, since rigidity of an embedment form is generally small, it should be sufficiently examined in advance. If necessary, reinforced so that cracks do not occur due to lateral pressure of concrete. Fiber sheets attached to forms for purpose of water permeation or water absorption. Fiber sheets attached to forms for purpose of water permeation or water absorption should be securely fixed securely fixed. Securely fixed to forms. Can say fiber sheet attached to forms of a purpose of water permeation or water absorption should be securely fixed to forms with adhesive tape, stapler, etc., so that neither slack nor wrinkle may arise. When fiber sheet is reused, whatever attached waste shall be removed and sheet properly cleaned to ensure full functional performance of fiber sheet. Now slip form. A slip form. In design of slip form, let me see what's the status of signals. And time is about 1.5 hours. Okay, let's go. In design of slip form, in addition to loads referred to section, spatial loads such as frictional forces be appropriately considered. A slip form shall be moved continuously. A slip form shall be moved continuously until structure is completed, or you can say a slip form shall be moved continuously until the structure is completed or construction of plane section is finished. Plane section is finished. Formwork system shall have sufficient strength and rigidity, and all ancillaries should have required capacity and be safe for use. Formwork made of metal plates should be used. Rate of movement of slip form shall be determined in a manner that ensures the strength of concrete immediately after removal of slip form is sufficient and sufficient to resist all possible loads, taking into account quality of concrete and conditions of construction. Appropriate measures for securing concrete durability shall be taken when constructing using slip form. When slip form is used in addition to loads expected on general construction methods, following special loads shall be considered at top of steel frames or jacking rods during placing of concrete. Weight of deck, friction between concrete and formwork, weight of reinforcing bars temporarily placed on deck, and weight of concrete acting on temporary deck or working deck, which can be used as shores of bottom formwork. When theoretical loads are difficult to calculate, design should be based on result from an experiment unless safety of formwork has been proven from previous experience. Formwork system should have sufficient rigidity so as to ensure that deformations of structure do not exceed tolerances during sliding operations. Yoke a member like a gate frame. Supporting formwork and working deck should be able to resist lateral pressure of concrete and to transmit full weight of shuttering, accessories and decks to jacks. Yoke should also secure adequate clearing. Yoke should also secure adequate clearance to enable embedded material to be located correctly prior to being arranged in rising concrete. In design of a vertical slip form in which jacks are supported on vertical rods, care should be taken to place jacks in such a manner that vertical loads to each jack are as nearly equal as possible and that capacity of jacks are not exceeded. Jacking system should also provide for precise simultaneous movement of entire form at constant sliding rate. When placing concrete is interrupted before assumption, Before resuming construction, it is necessary to perform joint treatment. This is necessary in order to prevent a weak point in concrete which may reduce durability performance. In general, required compressive strength of concrete immediately after removal of formwork should be more than 2 times larger than stress induced by full load. In general, required compressive strength of concrete immediately after removal of formwork should be more than 2 times larger than stress induced by full load. As sliding rate is greatly affected by type of cement used, mixture proportion, temperature of fresh concrete and other factors, intended standard rate should be determined based on preliminary tests. When concrete immediately after removal is not expected to achieve required strength, when concrete immediately after removal is not expected to achieve required strength due to changes in weather or construction conditions, it is necessary to alter rate of movement or to take proper measures to achieve adequate strength. In addition, if concrete strength becomes too large, slip resistance may also increase and may exceed capacity of jack. Therefore, sufficient attention shall be paid to rate of movement. Since removal of slip forms will be carried out at an early age and it's hard to carry out sufficient curing, the slip form method compared with general construction method, curing method should be fully examined before in order to secure durability of concrete. Moreover, there is possibility that wrinkles may arise with movement of slip forms. So this will have an adverse impact not only on appearance but also on durability. When a fault is discovered after movement of slip form, extent of fault shall be evaluated and measures be taken if necessary. Movable shores. Movable shores shall be designed to have sufficient strength, safety and required performance. Movable shores shall be designed to have sufficient strength, safety and required performance. In cases when loads from movable shores are to be supported by existing structure, safety of such structure shall be confirmed for all load conditions. All supports on movable shores shall be regularly inspected after erection and during the period of operation to ensure performance and safety. Movement of movable shores shall be carried out accurately and safely. In cases when movable shores are used, it shall be ensured that assembly and operation shall not cause any adverse deformation in concrete. Adequate camber shall be provided for movable shores depending on requirement. Movable shores refer to herein. Movable shores we can say refer to here involve movable shores, movable suspended shores, working cars for overhanging erection, movable erection beams, and so on. Mobile shores involve mobile suspended shores, working cars for overhang erection, movable erection beams, and so on. Movable shores consist of formwork, shoring beams, extending beams, supporting posts, transmitting loads to existing path or ground. Other supports for horizontal or vertical movement and combined apparatus if necessary. Movable shores, because of their long service period, shall be designed for stability against uplift forces of wind as well as horizontal loads due to seismic and wind loads. In general, structure may face unstable conditions during movement of shores. Therefore, care should be taken. If necessary, loading tests should be conducted after erection of shores to confirm their safety. Movable shores should be moved while monitoring direction, height, and other factors to ensure that specified positions are obtained accurately and safely. If shores are moved before concrete achieves specified elastic modulus, concrete beam may be harmfully deformed. Consideration should be taken to avoid such a situation before commencement of construction work. Value of camber should be determined. Value of camber should be determined based on deflection caused by weight of concrete. Value of camber should be determined based on deflection caused by weight of concrete and other factors. Especially for pre-stressed concrete beams, camber should be determined considering elastic deformation and creep caused by pre-stressing. Now, cold weather concreting. Cold weather concrete. When mean daily temperature is likely to drop below 4 degrees Celsius. When mean daily temperature is likely to drop below 4 degrees Celsius. Provision for cold weather concrete shall apply. Mean daily temperature is likely to drop below 4 degrees Celsius. That's mean daily, remember. Cold is not daily temperature, mean daily temperature. Provisions for cold weathering conditions apply. In cold weather concreting, adequate care shall be taken in regards to transportation to site. Placing, transportation to site, placing, curing, formwork and shoring to ensure that fresh concrete does not freeze and that it has required qualities despite being placed in cold weather. Under weather conditions, When mean daily temperature is 4 degrees Celsius or below, casting of concrete should be carried out according to provisions for cold weather concrete, since setting and hardening reactions of concrete are markedly retarded. Since setting and hardening reactions of concrete are markedly retarded, and concrete may freeze even in daytime as well as at night or early in morning. When concrete is exposed to temperature below freezing before hardening, when concrete is exposed to temperature below freezing before hardening, it easily freezes, expands and suffers from frost damage at early ages. Concrete having suffered from frost damage at early ages shall never be restored to its strength even if followed by adequate curing. Consequently, properties as such as durability and water tightness shall be greatly deteriorated. When concrete is exposed to low temperature of about 5 degrees Celsius or below, setting and hardening reactions are considerably retarded, even though no freezing occurs. Hence, in structures subject to an early application of construction loads, problems such as cracks and residual deformation arise. When wind blows directly against exposed surface, when wind blows directly against exposed surface or steel made shuttering, temperature falls in concrete becomes much larger. Freezing temperature of concrete. Freezing temperature Freezing temperature of concrete is about minus zero point -5 to minus 2 degrees Celsius, although it slightly varies depending upon water cement ratio and type and amount of admixtures. Freezing temperature of concrete is about minus 0.5 to minus 2 degrees Celsius, although it slightly varies depending upon water cement ratio and type of amount of admixture. According to temperature data in Japan, freezing of concrete may occur not only in Hokkaido and Tohoku but also in other parts of country, including Shikoku and Kyushu. Important actions during cold weather conditions are concreting are to prevent concrete from freezing and to take necessary measures to prevent quality of concrete from deteriorating even under cold weather. Particular important considerations when trying to achieve these goals are as follows. Concrete shall be protected from freezing at early stages of setting and hardening. Concrete shall be given sufficient resistance against freezing and thawing action during period from completion of curing till weather gets warm. Sufficient strength shall be provided to withstand possible loads at different stages of materials. It's a standard requirement of Portland cement or type B blended cement should be used. Neither frozen aggregate nor aggregate containing ice or snow shall be used in that state. Chemical admixture shall be selected so that stable concrete quality can be obtained. chemical admixtures whose quality is not specified, such as freeze-preventing additives and scald-resistant additives, may be used only when their quality of concrete may be used by using such additives are fully verified. If metals are to be heated, only water and aggregates shall be heated. If metals are to be heated, only water or aggregates shall be heated. Cement shall not be heated directly under any circumstances. Aggregate shall be heated uniformly and by a method that doesn't cause aggregate to become dry. You can just wait on this for a few minutes. I'll be back that and we'll see what to do with this. I think it's about maybe little time now, and we'll see how to do it. We'll give it time for this. Okay. Sorry gentlemen, the use of Portland cement, you can say here. Use of Portland cement, as I said. As we said here, in this case, but of course there is disturbance here, something. Use of Portland cement or type B blended cement is required as a standard for cold weather concrete. What we say is this, we're talking of cold weather concrete, and it is said that we don't have to heat cement, but we can heat water or aggregate. Water or aggregate can be heated, cement cannot be heated. Under any circumstances, aggregate shall be heated uniformly and by a method that does not cause aggregate to become dry. We can use chemical admixtures, also selected one, so that stable concrete quality can be obtained. Chemical admixtures whose quality is not specified, such as freeze preventing additives and cold resistant additives, may be used only when respective quality and quality of concrete made by using such additives are fully verified. Use of Portland cement, it is difficult. In case it says use of Portland cement or type B blended cement is required as standard for cold weather concreting because degree of delay in strength development at early ages of concrete is low, even when concrete is cured at low temperature. In case of normal Portland cement, it is difficult to attain required curing temperature and initial strength. In absence of problems associated with cracking due to heat generated by hydration, it is desirable that high early strength Portland cement be used. High early strength Portland cement be used. High, you can say frozen aggregate or aggregate containing ice or snow used in that case, in that state, concrete mix becomes prone to problems such as lower mix temperature and fluctuations in water content, such that concrete quality is adversely affected when conducting cold weather concreting. Therefore, it is desirable that aggregates are stored in facilities where freezing and intrusion of ice and snow can be prevented. It is a standard requirement that chemical admixtures be used for cold weather concreting be selected from those that meet requirements. Chemical admixtures to be used shall also ensure stable quality of concrete even at low temperatures. Lowering water cement ratio by using an air and cleaning high range water reducing agent is effective for enhancing freezing resistance. Concrete made using an air-entraining high-range water-reducing agent has a smaller slump at lower temperature than at higher temperatures after mixing. But slump of such concrete may become large over time. It is therefore important to exercise care in using air-entraining high-range water-reducing agents and pay close attention to water-reducing performance at low temperature changes in workability. Besides chemical admixtures mentioned, other chemical admixtures that may be used, including freeze-preventing and cold-resistant additives. Besides chemical admixtures mentioned above, other chemical admixtures that may be used include freeze-preventing and cold-resistant additives. Accelerator type air entraining water reducing agent, accelerator type air entraining water reducing agents, and accelerator used to accelerate strength development. When using these chemical admixtures, it shall conduct careful studies on their composition, effects, etc., and ascertain quality. For liquid chemical admixture, it is also necessary to take measures to prevent them from freezing because a segregation occurs when these freeze. Before chemical admixture mentioned above, besides chemical admixtures mentioned above, other chemical admixtures that may be used include freeze preventing and cold resistant additives, accelerator type air entraining water reducing agents, and accelerators used to accelerate strength development. When using these chemical admixtures, it shall conduct careful studies on their composition, effects, etc., and ascertain their quality. For liquid chemical admixtures, it is also necessary to take measures to prevent them from freezing because segregation occurs when they freeze. If high temperature cement is allowed to come into contact with water, cement may harden quickly with adverse effects on concrete. Cement therefore shall not be heated. If materials are to be heated, it is desirable that water also be heated because it is simple to perform and heat capacity of water is large. Temperature of heated water shall be controlled so that cement does not harden quickly. Capacity of equipment and methods used to heat water requires to be sufficiently large so that temperature of materials to be heated is raised uniformly and large target temperature can be obtained for selected materials. Capacity of equipment and methods used to heat water requires to be sufficiently large so that temperature of materials to be heated is raised uniformly and target temperature can be obtained for selected materials. Raising temperature of aggregate to 65 degrees or higher, 65 degrees Celsius or higher, may make aggregate difficult to handle and cause cement to harden quickly. In general, these problems can be prevented by keeping temperature of water aggregate mixture at or below 40 degrees Celsius. These problems of handling hot aggregate in general can be prevented by keeping temperature of water aggregate mixture at or below 40 degrees Celsius. Method of using steam to heat aggregate is relatively easy to control. When metals are heated, concrete temperature in degrees Celsius just after mixing can be calculated by following equation, and it's here that is T is equal to Cs. Specific heat of cement and aggregate assumed to be 0.2. Cs is specific heat of cement aggregate, and TA and WA weight and temperature of aggregate in kilogram and degrees Celsius. That is WA, weight and temperature of aggregate. Okay. TC, WC, WCTC, weight and temperature of cement in kilogram degrees Celsius. And TM, WM, weight and temperature of mixing water in kilograms, this much. And then you can say this division of this, WA plus WC WM. And here is mixed proportions. As a general rule, concrete placed under cold weather should be air entrained concrete. Air entrained concrete placed under cold weather should be air entrained. As a general rule, concrete placed under cold weather should be air entrained. In order to prevent initial freeze damage, water content shall be made as low as possible while maintaining required workability. Use of an air entraining agent or air entraining water reducing agent. Use of an air entraining agent or air entraining water reducing agent makes it possible to entrain air bubbles. Use of an air entraining agent or air entraining water reducing agent makes it possible to entrain air bubbles so as to reduce water content required to attain required workability and to reduce adverse effects due to freezing of water in concrete. This is why it is required that air entrained concrete be used when concrete is to be placed under cold weather. What it says, use of air entraining agent or air entraining water reducing agent makes it possible to entrain air bubbles so as required to attain required workability and to reduce adverse effects due to freezing of water in concrete. That's why it's required that air entrained concrete be used when concrete is to be placed under cold weather. Standard air content is 4% of volume of concrete upon completion of mixing. In cases where concrete is likely to be subject to freeze-thaw cycle over a long period of time, for example in a cold region, it's a good practice to use an air content of about 6% after confirming that strength requirements are met. In general, slump increases as concrete temperature rises. In general, slump increases as concrete temperature rises. When concrete is produced in winter, therefore water content tends to be lowered to attain required slump. Lowering water content not only reduces amount of water that can freeze but also reduces bleeding, which tends to increase considerably at low temperatures and prevents concrete temperature from falling. Basic rule therefore is to reduce water content as much as possible to extent that required workability can be achieved. Concrete temperature just after mixing shall be such that required temperature at time of placing can be obtained, taking into consideration effect of weather conditions, time of transportation. In case heated materials are used, order in which metals are put into mixer shall be decided such that cement does not harden quickly. Concrete temperature just after mixing shall be controlled so as to minimize batch to batch variation. Concrete temperature at completion of placing is lower than that just after mixing in a mixer due to heat loss during transportation and placing. Extent of concrete temperature drop is usually regarded to be about 15 degrees of difference in temperature between concrete and ambient air for each hour of transportation and placing. It can be calculated by following equation. I repeat, concrete temperature at completion of placing is lower than that just after mixing or in a mixer due to heat loss during transportation and placing. Extent of concrete temperature drops is usually regarded to be 15% not degrees of difference in temperature between. The extent of concrete temperature drop is usually 15% of difference in temperature between concrete and ambient air for each hour of transportation and placing. It can be calculated. Say T2 is equal to T1 minus 0.05 minus 0.15 T1 minus T0. T0 is ambient air temperature in degrees Celsius. T1 is concrete temperature just after mixing. Just after mixing is higher and ambient temperature is lower, so that's that. And we can say T2 is concrete temperature at completion of placing. So concrete temperature at completion of placing is equal to concrete temperature just after mixing minus 0.15 into you can say ambient into concrete temperature just after mixing minus T0 ambient temperature. T is time from mixing to completion of placing in hours. Therefore, concrete temperature at mixing requires to be sum of required placing temperature. Concrete temperature at mixing requires to be sum of required placing temperature and heat loss during transportation and placement. In selection of ready mixed concrete plants, consider cement may harden quickly if high temperature water comes into contact with cement. A recommended procedure therefore is to put heated water and coarse aggregate and then fine aggregate into mixer, and finally after temperature of materials in mixer becomes 40 degrees Celsius or lower, put cement into mixer. If rate of supply of concrete exceeds the capacity of heating equipment, it's no longer possible to attain required as mixed temperature. If rate of supply of concrete exceeds capacity of heating equipment, it's no longer possible to attain required as mixed temperature. When planning for concrete placement, therefore, it shall take material heating capacity into consideration. Shall also take considerable care with first batch of day, because low equipment temperature may result in low as mixed temperature. Transporting and placing. Concrete shall be transported and placed so as to minimize reduction in temperature of concrete. Reduction in concrete temperature during transportation and placing shall be prevented by reducing time elapsed between mixing and placing of concrete as much as possible. Concrete shall be transported and placed so as to minimize reduction in temperature of concrete. Concrete shall be transported and placed so as to minimize reduction in temperature of concrete. Reduction in concrete temperature during transportation and placing shall be prevented by reducing time elapsed between mixing and placing of concrete as much as possible. Temperature of concrete at placement shall be in range of 5 to 20 degrees Celsius. Temperature of concrete at placement shall be in range of 5 to 20 degrees Celsius, considering cross-sectional dimensions of structure and weather conditions. Temperature of concrete at placement shall be in range of 5 to 20 degrees Celsius, considering cross-sectional dimensions of structure and weather conditions. It shall be ensured that snow or ice are not adhering to reinforcement form. To ensure that snow or ice do not adhere to reinforcement form work, etc. In case when surface of concrete at construction joint is frozen, it shall be appropriately thawed and fresh concrete shall be placed in accordance with provisions given. Surface of freshly placed concrete shall be protected from exposure to atmosphere for a long time. It is necessary to check on time required for transportation. It is necessary to all signals are 0, unfortunately again. If I continue, by chance I came to check this and it's 0, 0, 0. It's continuation of false signals really. I don't know, it's achievement by professional engineers working in this. Well, really surprising, really surprising to me and surprising to everybody. It is surprising to everybody. It is, and surprising to me. It is, really speaking. It's all same. It's no difference here. And it's all same. It's no difference here. You may see. Necessary to check on time required for transportation construction site and for process from temperature falls. During those processes, to take appropriate measures on an as needed basis. When a concrete pump is used, if temperature of conveyance pipe is too low, frozen mortar may stick to sides inside surface of pipe and may result in unexpected trouble. In order to prevent such trouble, it is necessary to carefully perform tasks such as maintaining temperature of piping, preheating by use of heated water prior to placement, and cleaning after completion of placement. Concreting tasks require to be controlled so that placement of concrete is not interrupted. For cold weather concreting, hardening of concrete may be retarded remarkably, and concrete is likely to freeze when ambient air temperature drops rapidly. Therefore, adequate concrete temperature shall be secured at placing of concrete, considering type and size of structures, weather conditions, ambient air temperature, and curing method. For case of severe weather conditions and thin concrete member, minimum temperature at placing or placement shall be secured at around 10 degrees Celsius. This is for case of severe weather conditions and thin concrete member. On the other hand, for a thick concrete member, thermal cracking tends to occur due to heat generated by cement hydration when temperature of placing concrete becomes higher. Therefore, temperature at placement of concrete may be controlled at 5 degrees Celsius or slightly higher for thick concrete members. When temperature is overly high, unit water content normally increases and hardening process of concrete is accelerated, resulting in decrease of strength at later stage. Furthermore, concrete surface becomes susceptible to drying and may cause cracking. Hence, considering such factors as size of structural members and weather conditions, concrete temperature at placing should be determined to be within a range of 5 to 20 degrees Celsius, so that freshly placed concrete shall not be subject to frost damage at early stages, since since low concrete temperature may cause lateral pressure and bleeding in to increase. Shall attention shall pay attention to placing rate, placing height, etc. It's effective to spray hot water. It's effective to spray hot water or steam on reinforcement and shuttering to melt ice and or snow. However, in case of lower temperatures, precautions should be taken because refreezing of water may cause adverse effects. Combined use of such equipment as burners and heaters with propane gas or kerosene is also effective. Combined use of such equipment as burners and heaters with propane gas or kerosene also effective. Melted water and water used melted water and water used for melting shall be removed prior to placement of concrete. In cases where concrete is placed on ground, if ground is frozen, concrete temperature falls sharply and frozen ground melts so that concrete settles. In cases where concrete is placed on ground, if ground is frozen, concrete temperature falls sharply and frozen ground melts so that concrete settles. When placing concrete on ground, it's necessary to cover ground with sheeting, etc. And if necessary, use floodlight equipment, heater to prevent ground from freezing before placement of concrete and prevent water inflow. In cases when ground is already frozen, concrete shall be carried out after it is properly melted. To state herein that concrete is frozen doesn't mean that concrete is subject to frost damage, but just describes the state of concrete. It's likely that temperature of concrete surface rapidly drop during elapsed time between completion of placing and start of curing. It's like the temperature of concrete between concrete surface may rapidly drop during elapsed time between completion of placing and start of curing. Therefore, concrete surface shall be covered immediately after placing. An appropriate material such as plastic sheet is especially important to protect concrete surface from wind. Curing. Curing. Method and duration of curing shall be decided considering such factors as ambient air temperature, mixed proportions and type and size of structures. Curing, we are talking, is a very important item for concrete production, and that's why we have to be very serious about this issue. So time is so much, let me see what time it is. It's about 2 hours 42 minutes. Still signals are down. I'm surprised to see people 0, 0 and 0. And I don't know anything about what is being recorded or what's not being recorded. That's the point where we have to be very serious about. What to do? Nothing in my hand, nothing in your hand. Curing is, very important item we have to deal with. It's not easy. Curing is very important item. We understand that. It's not always easy to get into its reference 00 and 00. I don't know what to do with this. Maybe nothing is recorded. Who knows? It's not showing any question on this. All 00 signals yet. I can't move forward until I'm sure. Still, all 3 points 0. I don't know. It's not moving yet. It's not moving yet. I'm going to see how long it takes. I think it's not working. So long time, never accepted, but maybe collapse this video. Nobody knows what's out of this. 00 and 00. More than a minute over. No signals. Let me see if I can. Otherwise, probably nothing yet. What can I say? Continuation of 0 means certainly this video shall fall. Better wait for a couple of seconds and see if something comes in. Otherwise, I don't know. Whereas this is 0, 0, 0. That's point here. Axis is showing axis, but it's not showing what should be. It's not showing what should be. Still axis is shown. Nobody knows long scene of 0, 0, 0. I'm still waiting. You must also experience that. People have to wait for nothing. I don't think it's working. It's still stopped. Still stopped. Action needed. It's required. Because some signals have come. Okay, good time. Some signals have come. Method and duration of curing. Method and duration of curing shall be decided considering such factors as ambient air temperature, mixed proportions and type and size of structure. During early age after placement, freshly placed concrete shall be sufficiently protected from being frozen, particularly from wind. Furthermore, during construction, temperatures of concrete and surrounding atmosphere shall be periodically measured, and plan for construction may be changed accordingly. So it says, furthermore, during construction, temperature of concrete and surrounding shall be periodically measured, and plan for construction may be changed according to, if necessary. Temperature of concrete exposed to severe weather should be maintained at 5 degrees higher, 5 degrees or higher until compressive strength reaches value given is stable. That's that. There is required compressive strength of concrete at end of curing under severe weather conditions. Exposure conditions, it is thin, ordinary, thick. This exposure conditions like portions, continuously or frequently. So let's see. Required compressive strength, exposure conditions, portions continuously or frequently saturated with water, thin member 15 and ordinary 12. Weather conditions, thick is 10. So thick is less temperature, ordinary is more temperature, and thin is more than that. Portions exposed to ordinary conditions, other this one, it's possible. 5 for thin, 5 for ordinary, and 5 for thick. When heating of concrete, as when heating of concrete, rapid drying of concrete shall be avoided, and heating shall be conducted uniformly in concrete. Concrete shall be cured until it achieves required strength that can withstand possible loads during construction. After completion of insulation curing, or after completion of insulation curing or heat curing, concrete shall not be cooled rapidly. Curing methods for cold weather concreting are classified into insulated curing and heat curing. These are insulated curing and heat curing. Regarding insulated curing, concrete's surroundings are covered with materials of high insulation performance, and curing is continued until required strength develops by utilizing heat of hydration of cement itself. Heat curing is conducted for lower ambient air temperatures and thin concrete sections when it is impossible to adequately keep temperature above freezing point by insulation alone. Heat curing is conducted for lower ambient air temperatures and thin concrete sections when it is impossible to adequately keep temperature above freezing point by insulation alone. It is recommended to combine heat curing with insulated curing. It is recommended to combine heat curing with insulated curing using sheets in order to optimize its effectiveness. Heating apparatus of various properties are available, and effectiveness of their capacities, number of apparatus to be used, and arrangement of locations required to be examined. Since carbon monoxide may be produced depending on types of apparatus used, close attention shall be paid to safety control. When curing temperature increases, strength development of concrete is expected, and duration of concrete can be shortened, though curing is likely to occur during cool down period after termination of curing. On the other hand, when curing temperatures decreases, curing time until required concrete strength is achieved is prolonged. Therefore, it shall plan curing method during and duration and curing. Therefore, shall plan curing method, duration, and curing temperature while considering concrete mixture of proportions, strength, structural type, thickness of cross-sectional area, ambient air temperature, and so on. Once concrete suffers frost damage at early ages, and strength develops only slightly, even if curing is continually performed. Therefore, prevention of concrete freezing placed at any location should be implemented until required strength is obtained. Particular care shall be taken for curing of corners and edges of concrete structures, as these locations are most difficult to properly insulate and are vulnerable to frost damage at early ages. For cold weather concreting, temperature of both concrete and surrounding atmospheric air should always be monitored so as to avoid whatever problems related to concrete strength development. When conditions differ from plans, when construction conditions differ from plans such that concrete may be adversely affected, necessary countermeasures such as increased temperature or heat insulation, etc. When construction conditions differ from plans such that concrete may be adversely affected, necessary countermeasures such as increased temperature of concrete materials, insulated curing and heat curing shall be taken. Since wind expedites moisture evaporation, from concrete surface and lowers concrete temperature at or near surface, surface concrete shall be protected from cold wind immediately after pressing. Since, since wind expedites moisture evaporation from concrete surface and lowers concrete temperature at or near surface, surface concrete shall be protected from cold wind immediately after placing. Since wind expedites moisture evaporation from concrete surface and lowers concrete temperature at or near surface, surface concrete shall be protected from cold wind immediately after placing. We shall determine curing temperature considering mixture methods and lowest curing temperature with regard to protection from frost damage. Protection from frost damage at early ages is 5 degrees. For severe cold weather or thin concrete member, it may be increased sometimes increases up to 20 degrees Celsius due to heat of hydration. In general, appropriate curing degrees Celsius. The ranges in this actually 20 degrees is common one, which is very used in sites. I go further on this. Meanwhile, let me see time also. What time it is here? This 45. No, just a minute, please. Section. Since temperature sometimes increases up to 20 degrees Celsius due to heat of hydration, in general, appropriate curing methods are required so as not to increase temperature of surface concrete higher than size required performance to withstand frost damage cannot be specified by strength alone. Curing shall be continued until further further strength development is achieved. Concrete strength necessary to withstand frost damage at end of curing depends on factors such as weather conditions. Since it's a very important point that concrete, however, in case of wet concrete, continuously is subject to severe weather conditions, curing shall be continued until further strength development is achieved. Concrete strength necessary to withstand frost damage at end of curing depends on factors such as weather conditions, size of members, X-force conditions. Standard concrete strength is provided in table according to classification prescribed therein. These strength values are for prevention of concrete under rapid cooling. It has been concluded the mixture proportions and curing temperature affect curing period necessary to achieve strength. This is 5 and 10 general curing criteria is 5 and 10 degrees Celsius in order to maintain wet conditions. Period specified shall be satisfied as well. What is that? Criteria for curing periods to achieve specified compressive strength. As said before, exposure conditions, portions continuously or frequently saturated water and portion exposed to ordinary conditions other than none. Type of cement, first of all we have to see temperature column 510. Two are there, portions continuously frequently saturated with water, portions exposed to ordinary conditions. And there are ordinary Portlands 9 days, 7 days, 4 days, 3 days, and ordinary higher release strength days 5, 4, 3, 2, 1. Blended cement 12, 9, 5, 4. Water cement is 0.55, need to be modified for different WC. That is, or in type of cement, ordinary Portland cement, temperature is 5 and 10. That is in 9 days, 7 days. Curing period is 9 days or 7 days if it's 10 degrees Celsius. Same way, other one is 510. It's 4 days and 3 days. Portion is exposed to ordinary conditions, and you're exposed to saturated water. In that case, 9-7, it's 4 and 3, approximately less than half. High early strength is the